Let us study first the xenon fluorides. Xenon forms three types of fluorides: XeF2, XeF4 and XeF6. Xenon difluoride, tetrafluoride, hexafluoride. Now what we need to understand is that xenon combines with fluorine at around, if 673 Kelvin, in which when xenon is in excess, we get xenon difluoride. When this xenon and fluorine are taken in 1:5 ratio at 873 Kelvin at around 2 bar pressure, we get xenon tetrafluoride. When this xenon and fluorine are taken in 1:20 ratio, that means fluorine is in excess, at around 573 Kelvin and at around 7 bar pressure, we get xenon hexafluoride. So this is how these three fluorides are formed. Now all these fluorides, xenon fluorides, are colorless, volatile solids where they are very strong oxidizing as well as fluorinating agents. Now let us see their properties. All of these undergoes hydrolysis. When this XeF2 is combined with water, it forms Xe, HF and O2. That's a redox reaction. Xenon gets reduced and the oxygen gets oxidized. When this XeF4 is combined with water, is treated with water, it shows disproportionate reaction and forms xenon plus xenon oxide plus HF plus O2. So from +4 to it goes down to 0 to +6. So it's a disproportionate reaction which shows xenon is not stable in its intermediate +4 state. Whereas when this xenon hexafluoride is reacted with water, that means 3 molecules of water, what we get is xenon oxide and HF. So that's very different reaction, and this is one of the reactions which is actually is the preparation method of your xenon oxide. So in this it gets simply hydrolyzed and it changes to its corresponding oxide. Now what you need to know, another thing is that this xenon hexafluoride undergoes partial hydrolysis also and it forms XeOF4. It forms XeOF4 and HF once we take water, 1 molecule of water, and if it is taken with some more amount of water, that means in about 2 molecules of water, what we get is XeO2F2 plus HF. These are its partial hydrolysis. This is its complete hydrolysis. So you can see that the same compounds, when combined with different molecules of or in different ratios with water, forms different compounds. So these are two preparation methods of xenon oxyfluorides also. Another important thing about these xenon fluorides is that they combines with the fluoride acceptors as to form what the cations, and with fluoride donors as fluoroanions. Like if we take XeF2 with PF5 phosphorus pentafluoride, it forms XeF plus and PF6 minus. So it is existing as a xenon cation or fluorocation. Then if the same XeF6 is combined with MF, now here M can be your sodium or potassium or rubidium or cesium, it forms what? It forms M plus and XeF7 minus. So here it is actually existing as fluoroanion, so it accepts anion, a fluorine. So this is how these are the properties of xenon fluorides.